For today, we will discuss another gas law that describes the relationship of different properties of gases. Today, let's talk about the Charles law. Here's an example of an experiment that shows Charles law. Let's observe and answer this question.
In our second attempt, we used a full-size 12-inch party balloon and less water. We also placed a lid on the top to contain the hot air inside the beaker. In this version of our experiment, we see a more dramatic change in the balloon's size, as well as a much lower risk of the balloon popping. For the second portion of our experiment, we're going to place a balloon into the freezer. Leave your balloon in the freezer for a few hours. After a couple of hours, when we remove our balloon from the freezer, we'll notice it's smaller in size. As it warms up, it will gradually increase in size.
On this experiment, it shows the relationship of volume and temperature. As the volume changes, there is also a change on the temperature. This gas law is proposed by Jack Charles as he dropped a sample of gas in a cylinder with a movable piston in water bath at different temperatures. Now, to discuss the Charles law, let's have another look on the experiment to describe the properties of gases. And to answer this question, what happens to the balloon after it is put on a hot water? Now, as you can see, the balloon gets bigger or expand. Now, what happens to the volume and temperature of a gas on this example? The answer is the volume of a gas increases, the temperature of the gas also increases. The temperature of the gas inside the balloon increases because of the hot water that results to the gas molecules to move faster and expand and to occupy larger space and to increase its volume. Now, how about if the balloon is put on a freezer? What happens to the size of the balloon?
For the second portion of our experiment, we're going to place a balloon into the freezer. Leave your balloon in the freezer for a few hours. After a couple of hours, when we remove our balloon from the freezer, we'll notice it's smaller in size.
So the balloon gets smaller in size or it shrinks. Now how about the volume and temperature of a gas on this example?
For the second portion of our experiment, we're going to place a balloon into the freezer. Leave your balloon in the freezer for a few hours. After a couple of hours, when we remove our balloon from the freezer, we'll notice it's smaller in size.
The temperature of the gas inside the balloon decreases because of the cold temperature inside the fridge. That results to the gas molecules to move slower and compress and also to occupy smaller space or to decrease its volume. So on this example, the volume of a gas decreases as the temperature also decreases. Now here is what happens on the gas particles inside the balloon as the temperature increases because of hot water. The volume of a gas also increases. And this causes the size of the balloon to enlarge. Now, as the temperature decreases because of the cold temperature on the fridge, the volume of the gas also decreases and causes the size of the balloon to become smaller. Now, to sum it up, let's complete this sentence. Charles' law: as the temperature increases, the volume also increases. as the temperature decreases, that volume will also decrease. So if the pressure is held constant, the volume of a given amount of gas is directly proportional to its temperature. When we say directly proportional, as one property increases, the other one will also increases. And if one quantity or property decreases, the other one will also decreases. Now, to show further the relationship of volume and temperature of a gas, let's plot it on a graph. Let's say we have a cylinder that has an initial volume of 1 liter with 100 Kelvin as a temperature, experience a change to have 2 liters with 200 Kelvin as a temperature. Then another change happens on this gas present on a cylinder for them to have 4 liter of volume and 300 Kelvin as a temperature. A gas on a cylinder experiences a change on its volume and temperature while the pressure remains constant or do not change. Now, here is the table to sum up the informations on this example. Now, let's plot it on a graph. Now, as you can see, the volume of a gas on this example increases from 1 liter to 4 liter. As it increases its volume, the temperature also increases from 100 Kelvin. It increases to 300 Kelvin. So Charles' law states that if the pressure is held constant or do not change, the volume of a given amount of gas is directly proportional to its temperature, meaning to say, as the volume increases, the temperature will also increase. Here is some real-life example of Charles' law. First, tires of untouched vehicles get deflated during freezing winter days while get inflated in hot summer days. In winter, due to low temperature, the air inside the tire gets cooler and they shrink, while in hot days, the air expands with temperature. It is also why it is used as a precaution during summer days to always check the tires because of the high temperature we experience during summer. Next one is the expansion or enlargement of dough as you bake a bread or a cake. So a yeast is a leavening agent belonging to fungi that converts sugar in the dough to carbon dioxide gas. When the bread and cakes are baked, this conversion of sugar into carbon dioxide is accelerated and the gas liberating expands because of high temperature in the oven. Last one is the expansion and compression happens on our lungs during winter or colder days and summer or hotter days. In winters, the temperature of air decreases as a consequence, the temperature of air inside the body also decreases. Hence, the volume of the air decreases with the temperature. It shrinks the lungs, and the physical activities like jogging becomes difficult in freezing winter days. So now, there you have it, the Charles law. You can now proceed to your activities. Thank you.